Okay, so let's take a look at differentiating sine and cos. First thing we need to make sure that we do here is that when we are conducting calculus on, and that's differentiating or integrating trigonometry, our calculator must be in radians mode. Okay, so as a wee introduction to this, let's look at the graphs of sine x and cos x. So in order to differentiate sine and cos, what I want to do is locate my stationary points and then pull them down to the x-axis below and draw the graphs of the differentiated curves. Okay, so that would then give me a graph that looks like this. And for the cos graph, pull the stationary points down. So I've got one here, I've got one here, and I've got one here. So it's decreasing and then increasing, so I'm going to be below the x-axis and then above the x-axis. Apologies for my poor diagrams. So what does that tell us then? That tells us that when we differentiate sine, we get cos, and when we differentiate cos, we get negative sine. Just the sine graph turned upside down. Okay, so if y is equal to sine x, then dy by dx is going to be equal to cos x. If y equals cos x, then dy by dx is equal to negative sine x. And it might be worth remembering this wee path. So if we have sine and we differentiate it, we get cos. If we differentiate cos, we get minus sine. If we differentiate minus sine, we get minus cos. Differentiate minus cos, we go all the way back to sine. Okay? It might be worth your while remembering this. Okay, it'll make this a lot easier for you. So example 20, if y is equal to 4 sine x, differentiate 4 sine, I'm going to get 4 cos. So dy by dx is equal to 4 cos x. If f of x is 2 cos x, then f dashed x is going to be minus 2 sine x. If g of x is minus half cos x, then g dashed x minus cos goes to positive sine, I should say. It's going to be a half sine x. And then find dh by dk. So minus 5 sine k is going to go to minus 5 cos k. 2 cos k goes to minus 2 sine k. Okay. Example 21, I want to find f dashed of pi over 3. So let's differentiate first of all. So f of x is sine x minus 2 cos x. So f dashed x is going to be cos x minus cos goes to positive sine, so it's going to be plus 2 sine x. Then I'm going to sub in my pi over 3. So f dashed of pi over 3. Now this is where you have to make sure just now your calculator is in radians mode. Later on in the course, you'll be able to do this without a calculator at all. But for just now, because you haven't learned about exact values, you're just going to type into your calculator cos of pi over 3 plus 2 sine of pi over 3. Okay. So that's going to give me, let me just type it into my calculator just now. Cos of pi over 3 plus 2 times the sine of pi over 3. And that gives me 2.23. Okay. Example 22, we want to find the equation of the tangent. We've done this before. So we've got our x value, we need to get our corresponding y value first of all. So I'll say when x is equal to pi over 6, y is equal to sine of pi over 6, which gives us a half. So my coordinate is the point pi over 6, a half. To get the gradient, we have to differentiate. So dy by dx is equal to cos x. So when x is equal to pi over 6, dy by dx is cos of pi over 6, which will give me root 3 over 2. Okay? So my gradient is root 3 over 2. Put it into y minus b now. So y minus b is equal to m bracket x minus a. So I get y minus a half is equal to root 3 over 2 bracket x minus pi over 6. And again, just use your calculator. So you would just get y is equal to root 3 over 2 x plus root 3 pi plus 6 all over 12. That's if you have a Casio calculator. If you don't, then it might turn out something like root 3 over 2x plus 0.95. Just now, I'm happy to accept both. But as I say, later in the course, you'll be doing this as part of your non-calculator work, and you'll be using exact values. So just now, that's absolutely fine. Okay?